So we have seen about the elastic collision. Now we are going for inelastic collision. So we know that what is elastic collision. So when we have a substance, there is a collision with a proton which is having an energy of h nu. So after collision, it goes to the virtual state. So at this virtual state, it exists together in a different form, like it may exist this way, and this virtual state is not stable, and it will come back to the original state. And while coming back, the energy may be like imagine EA is the initial energy and EB is the final energy. And if initial energy as well as final energy is same, that is called as the Reliance scattering. And similarly, the frequency, incident frequency and scattered frequency is same, that is called Reliance scattering. So this comes under the elastic collision. If these are not equal, that comes from under the inelastic collision. So now I will explain all three lines in the diagram, like it will be very easy to remember. So here we have ground state and excited state, and this is the virtual state. And here we have so initially the molecule is at ground state. So after collision with a proton which is having an energy of h nu, it goes to this virtual state. This is called virtual state. Okay, so now, so this here, it will not stay for a long time, so it has to come back to it can come back to here, or it can come back to excited state also. Two possibilities are there. Imagine it came back to the ground state, and the the radiation is scattered. So what after means here the collision has takes place in the virtual state, they exist like this, and after that the whatever h nu we have here, that means like whatever the photon is there, so that will like from here that eliminate as a, I mean we can say scattered radiation, it gets scattered. Okay, now the incident radiation and scattered radiation is same. If incident radiation as well as scattered radiation is same, and similarly initial energy and final energy is same, that is called as a Reliance scattering. So this comes under this diagram is for the Reliance scattering. Okay, Reliance line, I think the spelling I am not sure, I think this is the correct spelling, Reliance line, I think this is the correct, I am not sure. And this is about the elastic collision, and we'll go for the inelastic collision. So we'll take this first, we'll take this. Now the molecule is at a ground state, so after a collision with a proton, it goes from the ground state to excited state. Now, and if imagine that it is coming back to the excited state only, and the scatter radiation is here h nu dash. Okay, so by seeing the diagram itself, we can identify that the initial energy and final energy is not same. Okay, because here see, we know that it's very easy to remember. We know the ground state and excited state. So which one is more stable? So ground state is more stable. So ground state is more stable, and it's having a less energy we can say. But excited state is having a higher energy, right? So just apply this concept here. So this is the ground state and this is the excited state. Now when the molecule is at ground state, that is having less energy, that we can call it as a initial energy, and it went after collision with proton, it went to the virtual state and it came back to the excited state. It did not come to the ground state. Okay, it stopped at excited state. That means the energy of at this point at the excited state, the same molecule which was there in the ground state will be having higher energy, right? So here imagine this is a molecule is there. After collision with proton, it went to the virtual state and it came back to the excited state, not to the ground state. So now what will happen to energy? Energy will increase. So just remember that. Now this is EB. So EB is greater than EA. This is the about energy. Now we'll go for the frequency. So now what is happening to the frequency? Now see, here it's very simple. The energy is increasing. That means some radiation is transferring. This is a substance. Okay, here it is there. So this is the molecule and here we have proton. So during collision at this stage, some radiation is transferring from the proton to molecule. So because of that reason, the energy is increasing, right? So that's why scattered radiation is less than the incident radiation. So we know that energy is final energy is greater than initial energy because the molecule is ending at the excited state, and because some radiation is transferring from the proton to the molecule, because of that reason the energy is increasing. So because of that, the scattered radiation is less than the incident radiation. So this is called inelastic collision, and this is for the Stokes lines. Okay, now and one more thing I would like to raise here. So as we know that frequency, if higher the frequency, that will comes at a less lambda max. We know this one, right? Okay, so in the examination point of view, if they ask a question that Stokes lines appears at which wavelength region, whether a higher lambda or lower lambda, if they ask a question. So as we know that if frequency increases, the lambda will decreases. So but here we can see that the scattered radiation is less here. So compare, so here this if you want to say whether the Stokes lines or anti-Stokes lines about their where it appears, whether it's a longer wavelength or shorter wavelength, so you have to consider only the scattered radiation, not the incident radiation. Okay, no, here now here the scattered radiation is less. So because of that, the Stokes lines appears at the higher lambda max range. Okay, higher lambda max means like more like towards visible region. Okay, so this is about the Stokes lines. Now we'll go for anti-Stokes lines. So it's just exactly opposite to the Stokes lines. In this case, the molecule which is at the excited state undergoes collision with a proton and it goes to the virtual state, and now it comes back to the ground state. Okay, so if you have understand this concept, whatever I said about the ground state and excited state, and it's very easy to I understand this also. Like see here, a molecule is there in the excited state. That means initial energy will be higher because it is at the excited state, and after collision it went to the virtual state and it came back to the ground state. Ground state is coming means it is a more stable means less energy. So initial energy is less than final energy, sorry, greater than final energy. Okay, because initial energy is at the excited state, final energy is at the ground state. Now so in this process we can see a energy loss. Okay, so we can also say that here the energy is losing. Because of that reason, the initial energy is greater than the final energy. Now what about the radiation? What about the frequency? Frequency here, this is exactly opposite. The incident frequency is greater than the scatter frequency. We can just just to remember, we can keep it like means like just for purpose of remembering. We can also think that whatever energy here we are losing, that is going to the proton. We can just remember like that. See, we have substance and proton. So during collision, some energy is transferring from here to here. That's why the scattered radiation is greater than the incident radiation. Just for remembering purpose, you can remember like this. Okay, so this is about the anti-Stokes lines. And one more thing I want to say here. If you see the Raman, like all collision, all lines, like so this is the relay line. This will be like this. Next, and left side will be Stokes lines, and right side will be anti-Stokes lines. This is Stokes lines, anti-Stokes lines, and this is, I am not sure about the spelling, relay line. So this is due to pure rotation. I will make video later on the rotation spectra. So this line is due to pure rotation, and these two are due to vibrational rotational. Vibration and rotation both will occur here. Vibration and rotation. So the main concept in the Raman spectra is change in polarizability. Okay, so here just by rotating the molecule, we are bringing the change in the polarizability. So because of that, we are getting a Rayleigh line. In case of Stokes lines and anti-Stokes lines, we are doing a vibrations as well as rotations. Okay, just remember this part. And one more thing, why Stokes lines are more intense compared to anti-Stokes lines. As you can see the length, the Stokes lines are more intense compared to the anti-Stokes lines. So this is very easy. So we know that in the ground state, and this is the ground state and this is the excited state, the number of molecules at ground state will be more compared to the excited state. Okay, and if you see this diagram here, this is Stokes lines and this is anti-Stokes lines. The Stokes lines is starting from the ground state. At the ground state, number of molecules will be more. Okay, so because of that reason, the Stokes lines are more intense, whereas in case of anti-Stokes lines, it's starting from the excited state. The number of molecules at excited state will be less. So because of that reason, anti-Stokes lines are less intense. This is about the two theories we have. Yesterday I have made a video on classical theory, and this comes under the quantum theory of Raman spectra. And next I will be making a video on the rotation Raman spectroscopy as well as vibration Raman spectroscopy. So if you have any doubts about these two videos, what I made till now on the Raman spectra, so you just write it in the comment box. If you like my video, please subscribe to my channel. Thank you.